SAM3 provides a strong frozen backbone for concept-prompted segmentation, but applying it directly to open vocabulary semantic segmentation is inefficient. You're running full-resolution decoding over the entire dataset vocabulary, even though any single image only contains a tiny active subset of classes. ActiveSAM solves this with a training-free, zero-shot inference framework that turns SAM3 into an active vocabulary segmenter. The core mechanism is image-conditional class pruning. We estimate an image-conditioned active set and only decode the retained classes, skipping the rest. The pipeline starts with contextual prompt expansion. Raw class names often lack semantic density. ActiveSAM canonicalizes input strings and enriches them with cached memory tokens. We retrieve the top two nearest neighbors in the frozen pooled text embedding space and append the first two WordNet hypernyms. This builds a richer prompt sequence for the decoder without updating any weights. Next is preview-driven class selection. We run a low-resolution presence preview at 672 pixels. We read only the presence logits from SAM3's presence head to estimate a class presence score. Crucially, we skip the segmentation head computation here to minimize latency. We select the active set using a quantile threshold of 0.8, which retains the top 20% of plausible classes, capped by a gating threshold of 40. This ensures we filter out noise while preventing the premature discarding of valid objects. Once the active set is determined, we evaluate the full-resolution image encoder once at 1008 pixels. Then we apply bucketed prompt multiplexing. We partition the active classes into buckets of size 32. For each bucket, the frozen grounding decoder processes the shared image features and the corresponding contextual prompts in a single forward pass. This reduces the number of decoder calls significantly compared to sequential decoding. We fuse instance and semantic scores via pixel-wise maximization. For background-aware benchmarks, we introduce margin-aware background calibration. Instead of a simple score threshold, we leverage the margin between the top 1 and top 2 class scores. We compute a calibrated confidence score that requires both high confidence and a clear separation from the runner-up, using a global exponent of 1.25 to sharpen the decision boundary. ActiveSAM outperforms the state-of-the-art SegErtho v3 by 1.4 mIoU on average across 8 benchmarks, while running up to 5.5 times faster on large vocabulary datasets. It also demonstrates strong robustness to corruptions like fog and motion blur. ActiveSAM proves that you don't need target domain training to improve efficiency. You just need to adapt the inference loop to the image content.